Very good morning, one and all. Welcome back to the day two of 3-day international faculty development program on the theme Engaging Minds and Empowering Success in the Modern Research Era. So today we have session number 3 and session number 4 on the topic data analytics using SPSS, parametric and non-parametric test. On the occasion, I extend warm welcome to all the participants for joining our session. So we have session number 3. It will gonna take at the time of 10 to 12 in the morning. Session number 2 during afternoon, 2 to 4. And we will be having a two assignment and one feedback form. And I request everybody immediately after the session, we will keep or we will drop the assignment link on the chat box, and it will be valid only for 15 minutes. If the session ends at 12 o'clock till 12:15, the feedback link and assignment link will be valid. They are here. After that, it will disappear. So we'll start the session number 3, that is data analytics using SPSS, parametric and non-parametric test. We have with us Dr. D. Kumarasan, Principal, Lakshmi Narayan Arts and Science College, Dharmapuri. On behalf of the college, as well as on behalf of our FTP program, I extend warm welcome to Dr. D. Kumarasan.
Thank you, sir.
Without wasting our time, now I request Ms. Pratiksha to introduce our eminent, experienced research scholar, that is Dr. D. Kumarasan. Okay.
Mr. Sajan, am I audible?
Yes, you are. You can.
Good morning, everyone. Dr. D. Kumarsan is MCom, MSc in Psychology, MBA, MA in English, MPhil, and PhD holder. He has been serving as a principal of Lakshmi Narayana Arts and Science College for Women, Dharmapuri. He is serving as a Senate member of Periyar University, Salem. His academic service spans over a period of 23 years in teaching and 18 years in research. He has acted as an external examiner for the conduct of PhD Public Viva Voce examination. His areas of specialization are financial management and marketing management. He has acted as a resource person for more than 80 international and national conferences and seminars, more than 20 webinars, and more than 100 motivational programs. He is prominent in performing data analysis with statistical package, that is SPSS, and has conducted over 70 workshops on research methodology and data analysis using SPSS in reputed universities and colleges in the various states of the country. He has published more than 35 papers in referred journals. He has been serving as a member of editorial board and peer review committee of reputed journals. He is a life member of Indian Academic Researchers Association. He has been honored with the awards like DLIT by the International Economics University of SAR countries, that is Republic of Maldives. Shiksha Ratan Puraskar, Lifetime Achievement Award by ESN Publications, Best Citizen of India Award, and Tiruvalluvar Ilakiya Award for his social service and literacy contributions. Swami Vivekananda Award, Kalvi Chudroli Award, and Sevai Chudar Award. He has got the opportunity to meet and travel along with the former President of India, Dr. APJ Abdul Kalam. It's our proud privilege to hear Dr. D. Kumarasan. Over to Mr. Sajan. Thank you.
Thank you, ma'am. And it's our pleasure to have such a wonderful resource person in our panel. So before starting our session, let me tell you the few things to all my participants again. Please mute your audio throughout your session. If you have any queries and questions, please put it in the Dropbox. At the end of the session, we will take up all your questions with our resource person. And whenever the resource person is sharing the screen, please don't mark anything on the screen. So this is a sincere request to everybody. And exact after session 3 for 15 minutes, we will drop the assignment and feedback link on the chat box. By saying this, let us start our session. Over to you, sir.
Thank you. Thank you, Dr. Sajan, for your wonderful organization of this 3 days webinar on research and data analytics. A warm, unpleasant morning to one and all for this 3-day workshop on research methodology and statistical analysis using SPSS. At the outset, I would like to thank the GDC team for having given me a wonderful opportunity to share some of my views on data analytics using SPSS, particularly parametric and non-parametric tests. I also thank the madam who has introduced me in a grand manner. Thank you, madam. So today's session, we have 2 sessions. One is in the morning and the other is in the afternoon. That is between 10 and 12, the first session, and between 2 and 4 will be the second session. During this session, we are going to discuss about the basics of SPSS as well as the parametric tests and non-parametric tests. So let us start with the basics, right from the basics, because Dr. Sajan already told me you can start with the fundamentals itself, sir. So let me start with that, right? So here, let me share the screens. Is it visible, sir?
Yes, sir, it is visible.
Okay, sir. So this is the data sheet of SPSS. You know pretty well. If you don't know, you just look at this view. There are 2 views here. See, data view and variable view. In the variable view, we have to define the variables. So how the variables are to be structured, how the variables are to be designed. For that purpose, this variable view is given. Then in the data view, all the variables we have defined in the variable view will appear here. Let me show one by one. So we will start with the variable view. So this is the first step or the first display when you open up a SPSS data sheet. So this is the data set of SPSS. So here, variable view. In variable view, so many columns are here. See at the top, you can see the columns. First column is meant for name, that is name of the variable. Then second one, type. Third one, width. Fourth one, decimal. Then next one, label. Then values. Then missing. Then columns, align. Then measure. Then roll. So of all these columns, let us consider major columns that are useful for data analysis. So here, first column, that is name of the variable. We know pretty well, variables can be broadly classified into dependent variable and independent variable. The variables which emerge as a phenomena without depending on any other variable are called independent variables. The variables which are dependent on one or more other variables are called dependent variables. Whatever it is, whether dependent variable or independent variable, we have a name for that variable. Here, there are 2 columns that are used to define the name of the variables. See here, first column is name and the 5th column, that is label. These 2 columns are meant for defining the name of the variable. Whereas in the case of the first column, the name should be entered in short form, not in full form, because we have certain syntax for entering the name of the variable in this column. There are two basic syntax. Number one, in this cell or in this column, if you are entering the name of any variable, suppose if the name of the variable contains two or more words, in such a case, here you cannot leave space in between two or more variables. This is one syntax. So what can we do? Instead of giving space in between two words, we can use underscore. We can use underscore. This is one syntax. And the second syntax that is very important is you cannot enter the same name for different variables. So one name can be assigned to one variable only. That's all. So these are the two main points we have to consider while entering the name. For example, I'm telling you the name of a variable is age group, for example. In this case, see, I am entering age. I am leaving a space and group. See, I have just typed, but when I press the enter button, an error message is appearing like this. That is, variable name contains an illegal character. Here, illegal character is nothing but the space. So what can we do? Instead of leaving a space, as I told you, we can use the underscore. So age underscore group. I just press enter button. Yes. No problem. Right? Similarly, the second one, I told you, no. What is the second syntax? The same name cannot be entered again. See, for the next variable, I am entering the same name. It is also not accepted. This variable name duplicates an existing variable name. So this is an error message. See here, that variable name has not been accepted. So these two are the main points you have to consider while entering the name of the variable. One is no space can be given in between two words of a name of the variable. And second one, the same name cannot be assigned for more than one variable. That's all. Right? So the first column is over. Let us come to the second column. This is the type of data. How the data is going to be. For that, see, there are three dots. If you click the three dots, you can see the different types of variables: numeric, comma, dot, scientific notation, date, dollar, custom currency, string, restricted numeric. Here width and decimal places are given. Of all these types of variables, we select the numeric data only. It is selected in default. See, at once I entered the name of the variable, the type of variable is being displayed as numeric. So it is selected in default. You need not change it. Then here also we have two more entries, that is width and decimal places. That is the next two column. So width means the size of the variable. So how many digits are going to be there. That is called width. It is given in default as 8. Let us leave it for the time being because we are not going to enter any variable more than 8 digits. So 8 digits is enough. The maximum number of digits in data is going to be 8 digits. That is called width. So leave it. Let us not change it. But the next column is meant for decimals. In default, it is given as 2 decimals. Decimal, I mean, 2 decimals are given. Normally, when we use the finance data, for example, an amount is entered. In that case, we will be using rupees and paise. In that case, decimal is required. Or in some other cases, if decimal is required, then let us keep it as 2 decimals, as in default. But when we enter the primary data, we are using the whole numbers only. So in that case, decimal need not be used. So what we have to do? We have to make it as 0. So either you can enter 0 in place of 2, you can enter 0 and press enter button. Or see, in default it was given as 2, no? Here you have up arrow and down arrow. If you click the down arrow, it is reduced. If you click the up arrow, it is increased. So what should we do? We have to press the down arrow so that it is neutralized to 0. Right? Then the label column. Label column is the actual definition of the name of the variable. See, in the first column, we have entered the name of the variable in short form. But here you can type or enter the name of the variable in full form as you want to have it displayed in your output. So here you can enter the full form of the name of the variable. Here there is no such syntax. See, let me enter age group of the respondents, whatever it is, right? See, I have entered age group of the respondents, right? Then here, values. It is also an important column which defines the values of the labels. See, age group of the respondents may be classified into different categories. Say, for example, up to 20 years, 20 to 40 years, 40 to 60 years, above 60 years, like that we can enter. So here what we have to do is, in default it is given as none. If no categorization is made, then we can take it as it is, that is none. Since we are categorizing the age group into different classes, we have to define the values. For that, you can press the 3 dots appearing here so that a window is appearing like this. That is value and label. Here, we assign certain values, whether it is meaningful or not. We are giving certain values. Say, for example, value 1 is entered. What is the label? Below 20 years. Then you click the add button. Then second, or value 2. It is meant for 20 to 40 years. Again add 3. 40 to 60 years. 40 to 60 years. See, I am deliberately committing a mistake. Instead of 40 to 60 years, I am intentionally entering some other number. Why I have done like that, I will explain. See, here I have to enter 40 to 60 years only. But I have wrongly entered as 40 to 61 years. So I have to change it. I have to change it. So if I have to change any value or label, then I have to select. I have selected now. See that highlighting is there. So that label is being selected. Now you go to this column and delete 1 and enter 0. So I have changed it, but it will be incorporated only after I click the change button. Yes, I have clicked the change button. See now what is displayed. The value 3 is assigned for the label 40 to 60 years. Okay. Then what is the fourth one? That is above 60 years. Above 60 years. I have to add. That's all. So value 1, 2, 3, and 4 are assigned for below 20 years, 20 to 40 years, 40 to 60 years, and above 60 years respectively. Right. After having given the values and labels, if suppose I don't want any of the labels anymore, suppose I want to delete this. I want to delete because I feel that it is no longer required. Then in that case, you select and click the remove button. See, it is removed. Again, no, I have removed by mistake. I want to enter it again. No problem. Enter 4 above 60 years. Add. That's all. Now you click OK. That's all. So enter. Label column. Then missing column. This missing will be used when some data are not entered in any column, then it will show what is the missing value. So here we need not use this column. So missing column need not be taken. Then the column meant for columns, that is in default 8, you leave it. Okay, because the width column, in the width column itself we have defined that it is 8. So here also column 8, it is in default 8, you just leave it. Then alignment, it is in default given as right, so you just leave it. Here also you need not do anything. Then here measure, there are 3 types of variables. See, number 1 scale, number 2 ordinal, number 3 nominal. There are 3 types of measures. One is nominal, second one is ordinal, and the third one is scale. What is nominal? If the values given here are just for the namesake, the values have no meaning. In such a case, we call it as, see, somebody is using a screen, Sajan.
Yes, somebody is using that. Please don't do it.
Okay. See here, as I told you, if the values are given just for the name shape. For example, the next variable I am entering as gender. So numeric as it is, 8 as it is, then it is put as 0, then gender. Now I assign the values here like 1 for male, 2 for female. See here, the numbers 1 and 2 have no real value because one can be assigned for male or one can be assigned for female according to your choice. So 1 for male, 2 for female, or 1 for female and 2 for male. There is no change in the meaning at all. So here it is called as the nominal variable. The values assigned are just numbers. It is just for identification. So there is no meaning in this at all. So we call it as nominal variable. We call it as nominal variable. Here also we have assigned just the numbers for identification. 1 for below 20 years, 2 for 20 to 40 years, 3 for 40 to 60 years, and 4 for above 60 years. But one thing we can see here is that the 4 values assigned to the 4 labels are in an order. See, below 20 years, 1. 20 to 40 years, 2. 40 to 60 years, 3. Above 60 years, 4. See, I cannot change the order, right? See, for example, if I want to change it, see, I have changed the order now. Will it be meaningful? Below 20 years first, 40 to 60 years second, 20 to 40 years third, above 40 years fourth. Will it be acceptable? No, because the order has been changed. So if the values are assigned on the basis of any order, that is called ordinal data. That is called ordinal data. So nominal data is just the name, the numbers are assigned. It can be replaced, either 1 for male, 2 for female, or 1 for female and 2 for male. We can change it. There is no change in the meaning. So we call it as nominal. But whereas in this case, 1 for below 20 years, 2 for 20 to 40 years, 3 for 40 to 60 years, and 4 for above 60 years. So it is in an order. So below 20, 20 to 40, 40 to, in an ascending order, or even it can be in a descending order, whatever it is in an order. So we call it as ordinal value, ordinal variable. Normally, if an order is there, first one I told you, no, nominal. You can remember easily, it is just for name, nominal name. So for the name shake, if you are assigning certain values, that is called nominal. If the values are assigned in an order, it is called ordinal. Sometimes we may have certain ranking questions. In that case also, see for example, ranking of futures of a product. In that case also, ranking of futures. How many futures we have given, right? See, for example, ranking of quality. Then ranking of price. Then ranking of availability. Then ranking of durability. Ranking of durability. Then ranking of quantity. Right? So we have considered 5 futures: quality, price, availability, durability, and quantity. We have asked the respondents to rank these futures, to rank the futures of the product. For this purpose, we have selected 5 futures: quality, price, availability, durability, and quantity. So normally 5 ranks will be given. The respondent has to assign the ranks to each of these futures. So here what values we have to enter is 1 for first rank, 2 for second rank, 3 for third rank, 4 for fourth rank, and 5 for fifth rank. Like this we have to enter. Here also it is an ordinal data. It is an ordinal data because here also the values are assigned in an order. So nominal value is just for the namesake. Ordinal data is just in an order we are assigning the values. It can be of 2 types. One is here we have assigned the values like the below 20 years for, 1 for below 20 years, 2 for 20 to 40 years, so 3 for 40 to 60 years, and 4 for above 60 years. Either it can be in an ascending order or in a descending order. We have assigned the values in an order. For this also we call it as ordinal data. And the other one, as I told you, ranking questions. So first rank, second rank, third rank, fourth rank, and fifth rank. So 1 for first rank, 2 for second rank, 3 for third rank, 4 for fourth rank, and 5 for fifth rank. So this is also an ordinal data, right? Okay. Now I have entered. Here also I have entered as ordinal data. See, for the next items, again I have to assign the values here. Is it not? 1 for first, 2 for second, 3 for third, 4 for fourth, and 5 for fifth. Like that I have to enter. But here we can copy and paste. We can copy and paste. Instead of typing again and again the same thing, we can copy and paste. So as usual, Control C. I have to select this cell and Control C. Then I change, I come to the next cell and I just enter Control V. See, that is enter. Control C, Control V, Control V, Control V. That's all. See here, everything is the same. Here, 1 for first, 2 for second, 3 for third, 4 for fourth, and 5 for fifth, like that. So for everything, it is entered simply by copying and pasting. Here, we have to change it into ordinal, right? Ordinal. You can just enter O, it will select ordinal. So then enter. See here, ordinal. I just type the O, so that ordinal is selected, then I enter ordinal. That's all. So here we have seen two types of data, nominal data and ordinal data. Then we can have scale data. For example, we are using 5-point Likert scale to assess the level of awareness, level of satisfaction, level of perception, or level of agreement, like that. For that purpose, we are using Likert's scale. Either it may be 5-point or 4-point or 3-point. That is called scale. For example, satisfaction on customer relationship management. So satisfaction on customer relationship management. See here, what are the levels of satisfaction we are using? 5-point scale we are using. So highly satisfied, means satisfied, then neither satisfied nor dissatisfied, or we can call it as neutral, then dissatisfied and highly dissatisfied. Here we take it as a scale data. So here the scale should be 5 for the, now we are assigning the scores, that is 5 for highly satisfied, 4 for satisfied, 3 for neutral, 2 for dissatisfied, and 1 for highly dissatisfied. So either we can enter in the same order, or even in the as usual in the ascending order we can enter. 1 for highly dissatisfied, 2 for dissatisfied, 3 for neutral, 4 for satisfied, 5 for highly satisfied. We have entered the scales. So here the data will be scale data. So what is nominal data, what is ordinal data, and what is scale data. Again, the next one is, suppose we are assessing the level of agreement, or for example, factors influencing purchase decision, or perception on the purchase decision, like that, or perception on the futures of a product, like that. So here perception on product variety, or brand, anything, brand futures, like that. Here also we will be giving several questions. So we are assessing the level of agreement. So here one thing you have to keep in mind, in the case of satisfaction, we are using the satisfaction on CRM. In the questionnaire, you have to write like this only, CRM, that's all. Customer relationship management, that's all. Suppose in the case of perception, we are analyzing the level of agreement. Whenever we consider the level of agreement, the question should be in a statement form. For example, here I have told you perception on product variety. So the question should be, varieties of products are available. So it is given in a statement form. Rather, as a product variety, in the questionnaire, the question should be constructed in a statement form, like this. That is, varieties of product are available. So it is given in a statement form. For that only, the respondents will be giving the responses like strongly agree, agree, neutral, disagree, and strongly disagree, like that. So here again we enter one for strongly disagree, two for disagree, three for neutral, four for agree, and five for strongly agree. That's all. Here also we call it as a scale data. That's all. So there are three types of data: nominal data, ordinal data, and scale data. Then another example. Suppose we have given certain numbers. For example, here in this case, we have obtained the data, that is age of the respondents, in the form of groups. We have collected the data in the form of age group. So we have entered the data as ordinal data. That is, we have assigned the values in an order. Instead of that, we can collect the exact age of the respondents also. That is age of the respondents. Here, no value is assigned. No value is assigned. So it is also called nominal. It is also called nominal. So there are two types of nominal data. One is no value is assigned. No value is assigned. In that case also we call it as nominal. Then here we assigned the values just for the namesake. No meaning in it at all. In that case also we call it as nominal data. Regarding the ordinal data also, I have given you two types of data. That is one for age group. So the values are assigned in an order. Or for the ranking questions also, we call it as ordinal data. Then regarding the satisfaction or perception, we have used the 5-point Likert scale. In that case, we call it as scale data. That's all. So I hope that you would have understood what is ordinal data, what is nominal data, and what is scale data. And the syntax, I told you, no, in the first column, name of the variable is entered. For that, we have certain syntax. What are the two syntax I have told you? One is no space can be provided in between two words. So let it be in the short form, not in the full form. So age space group, that will be the normal way of presenting the name of the variable. But here we cannot enter any space in between two words. So instead of using space, we are using underscore. So age underscore group. It is the name of the variable. But here in the label column, we are entering the full name of the variable. Age group of the respondents, age group of the customers, age group of the patients, age group of the students, like that we can enter. The age can be collected in two forms. Either the exact age is collected or the age is collected in group wise. Right? So if exact age is collected, it is called nominal data. If the age is collected in groups, we call it as ordinal data. That's all. Right? So that's all about the basics of variable definition. So we have defined the variables. Now we go to the data view. In the data view, you can see all these variables in the column heading. That's all. See here, age group, gender, ranking of quality, ranking of price, ranking of availability, ranking of durability, ranking of quantity, then satisfaction on CRM, then perception on product writing. Right? See here, any number of rows may be considered. See, what is your sample size? For example, you have collected data from 200 respondents, 300 respondents, 400 respondents, even 1000 respondents. No problem. You can just enter here. See here, you have to keep in mind what is the value we have assigned. See, for example, here that respondent has ticked or put a tick mark in 20 to 40 years. His response is age group of the respondents we have asked. He has put a tick mark in 20 to 40 years. So what is the value we have assigned for 20 to 40 years? It is 2. Right? So you have to enter 2. You have to enter 2. That's all. Then what is the gender? If suppose he is a male, what is the value we have assigned? 1. For male, we have assigned 1. Then ranking of quantity, quality, price, availability, durability, and quantity. See, any one rank can be assigned to any one feature. So quality may be assigned the second rank, price first rank, availability fifth rank, durability third rank, quantity fourth rank. So like this, one rank can be assigned to one feature only. So second rank for quality, first rank for price, fifth rank for availability, third rank for durability, and fourth rank for quantity. Right? What is the score we have assigned for satisfaction on CRM? The values we have assigned is 5 for highly satisfied, 4 for satisfied, 3 for neutral, 2 for dissatisfied, and 1 for highly dissatisfied. If suppose a particular respondent has put a tick mark on satisfied, so what is the score we have, what is the value we have assigned? 4. So 4. Okay. Then come to the perception. Perception, we have assigned 5 for strongly agree, 4 for agree, 3 for neutral, 2 for disagree, and 1 for strongly disagree. Suppose that respondent has put a tick mark on disagree, then we have to enter 2. Age. Already we have collected data in the form of age group. I have just shown here for your understanding. Right? Here the response given by him is 20 to 40. So maybe exact age is 24, for example. Okay. Like this, you have to enter data for all the respondents. So next one, 3, 2, here also 5, 2, 3, 4, 3, 1. So here 5, 5, 43, like that. Next one, age group 1, then male, then ranking 3, 2, 4, 1, 5, then here 3, 3, here 18 years, like that. Then here age group 4, female, ranking 1, 2, 3, 5, 4. Then here 2, here 4, here age is 67, like that. So like this we have entered the data, any number up to 200 respondents, up to 500 respondents, or up to 1000 respondents we can enter, right? See, after having assigned or after having entered the data, if suppose you want to check whether we have entered the correct values, in that case, see here I have selected this column and I can go to this icon. So value labels. If you click it, it displays the labels. It displays the labels. See 20 to 40 years, 40 to 60 years, below 20 years, above 60 years, male, female, second rank, fifth rank, third rank, first rank, like that. It displays the labels. If you want to see the values, again you click. That's all. So labels, values. Whatever you want, you can check it. That's all. Right? Okay. You want to ask any question, Sajan?
Yes, sir. One of the participant question here, might be he's practicing.
Okay.
Maftan Kodevar, his name. So he has a bit confused regarding the group age and age. He says that regarding group age, I think it should be nominal, not ordinal. Age, I think, would be scale, not nominal. I get a bit confused by these things. Please clarify, sir.
Okay, okay.
So he has a his explanation.
Yes. As I told you, age group is nominal, but the scores are assigned in an order. So we call it as ordinal. Right? If suppose we are assigning scores not in an order, in that case we call it as a nominal data. But here we have assigned the scores or the values of the labels in an order, so we call it as ordinal data. Right? Regarding the exact age, here we cannot say that it is ordinal because no values are assigned. See here, none. We have given the value of labels as none. So that only we call it as nominal. That's all. Okay?
Okay. I also have a question like how to code a negative statement in a Likert scale.
Negative. See, we are not assigning negative scores. We are giving the positive scores only because we are analyzing the quantitative data in positive sense only we are taking. No. So 5, 4, 3, 2. Rather, we can use it as -2, -1, 0, 1 and 2. We can assign it. But for the purpose of convenience, we are assigning 5, 4, 3, 2, 1. Because the Likert scale says that the scores should be assigned like this only. Since we are adopting the Likert scale, it is a standard scale. No, we are adopting the standard scale. So we assign the scores as 5, 4, 3, 2, 1 instead of -2, -1, 0, 1, 2, like that. Okay.
Yeah. And one more, sir.
Yes.
Exact age should be scale, I believe. What about the exact temperature, sir?
In that case also, we call it as the, again in the scale data, we have two sections, that is two types of data, that is interval data and ratio data, right? The ratio data has the real zero value, but in the interval data, there is no real zero. So in the case of temperature, we can have it as a ratio data, right? So ratio data and the interval data are there, right? So the scale data is again classified as interval data and ratio data. So the temperature is entered like that only. But here we are not using the temperature. It will be used in some other study relating to that temperature or anything like that. Okay,
Okay, so
right.
we'll continue, sir. Yeah.
Any other questions, sir?
Few questions are there. We will ask at the end, or else it will get
Okay,
delay.
okay, okay,
So
okay. Right.
yeah.
Right. Okay. So this is the very basic about the variable definition. Then we have entered the data, just some sample data we have entered. Now we have certain basic statistics. See, this is the analyze button. In the menu bar, we have analyze button. This is the only gateway to analyze the data. So if you click this, we have several analytical tools. Of all these tools, just we go for frequencies. We go for frequencies. If we want to have the frequencies only, then we click the frequencies, right? For which variable you want frequencies. Suppose, for example, you want to have the frequency for age group, you can select this. See, either you can select the variable and click this right arrow, it will be brought to this variable box, or otherwise you can just select it and drag it. Age group. So there are two methods in which the particular variable is entered in the variables box. Then go to the statistics. See, several statistics are here, but here we have assigned the values only. That is, just the numbers are assigned. As some other participant asked, it is just like that nominal value. But here, since it is in an order, we call it as ordinal variable. So analyze, descriptive, frequencies, we have entered this variable. Now click OK. See here, below 20 years, one respondent. 20 to 40 years, one respondent. 40 to 60 years, one respondent. Above 60 years, one respondent. So the percentage is 25, 25, 25, and 25. Then this is valid percentage. Then this is cumulative percentage. So what is the difference between actual percentage and valid percentage? Right? See, let me go to the data again. See here, suppose in this case, by mistake, I have not entered anything here, right? See here, I have missed some data. I have not entered any data here. See, you can see a small dot in this cell. Is it visible? You can just see a small dot is there. That means something is missing. Something is missing. Now, if you go to analysis for the same one, see, you can see now the difference in the results. So below 20 years, 1, 20 to 40 years, 1, 40 to 60 years, 1, above 60 years, 1. See, missing 1. Something is missing. So for one data, we have not entered anything. We have not entered anything. For one item, we have not entered anything. So here percentage. This percentage is calculated on the basis of total. On the basis of total. That is, see here, how many data we have entered? 5 data. So 5 is considered as 100%. So in this case, there is one respondent. So 20%. 20%, 20%, 20%, like that. But here valid percentage is considered for this total actual data entered, leaving the missed item. With that, the valid percentage is calculated. Whereas in the previous case, both are same because nothing is missed. But here, something is missed. So the percentage is changed from the actual percentage to the valid percentage. In this case, since something is missing, we have to take the valid percentage only. For that only, the cumulative percentage is given. That's all. So this is one thing. Then, other thing, here, suppose after, see, in this case, age is there. See, for all these other variables, right, let me clear this. Suppose I don't want this variable. I don't want this, this item. I can delete this. See, select. You just select from the leftmost column. You just left click the leftmost column. Then right click. Clear. Clear. It is cleared. Right? So here we have entered 4 cases. 1, 2, 3, 4 and 3 and 4. See, in the age group, we have assigned just the values. Gender, just values. Ranking, just value, just numbers. Numbers, 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 numbers. In the age column only, we have entered the actual age of the respondents. Here, the SPSS software is just like a mixie or a grinder used at home, because whatever data you feed in, it will analyze and give you an output. But the thing is, it should be meaningful. It should be meaningful. Here, we have entered some quantities. For all these columns, we have entered certain numbers. They are just numbers assigned to the labels, but they have no meaning. Either it is a nominal data, or it is an ordinal data, or even if it is a scale data, we have entered just the value of the labels. But here only we have assigned the actual values and no value of labels are entered. So this is what the actual value. So we can compute the mean or average or standard deviation for this data only. For all these data, we can compute the mean using this software, but it is not meaningful. The meaningful average is only for the exact value of age. So you can calculate mean age for this data only. So for this, go to analyze. Go to analyze. Go to descriptives. Go to descriptives. Here you select the age, not the age group. Age is selected. What are the options? Go to options. We can have mean, standard deviation, minimum and maximum. In default, these descriptives have been selected, you just press the continue button. Then OK. See, we have got the results. See here, number of respondents 4, minimum 18, maximum 67, mean 38, standard deviation 22.076. See, look at the data. See, what is the minimum? 24. 18. Minimum 24. Maximum 67. Our output also says that minimum value is 18 and the maximum value is 67. So the mean value computed is 38. See, as I told you, for the other variables also, for example, gender or the ranking, for the ranking also, I can find out the mean, minimum, maximum, mean, standard deviation. The software will give you the result, but it is not meaningful because it is not the actual value. The value of labels have no meaning. Either it is an ordinal data, or it is a nominal data, or it is a scale data. We have assigned just the numbers, like serial numbers, or it is just for identity, that's all. So here, even though the software gives us the mean, standard deviation, minimum and maximum, there is no meaning at all. So for this type of data, we should not use the mean or standard deviation or anything else. Now, just we shall understand what is a parametric test and what is a non-parametric test. A simple definition I can give you. Whenever some parameters are used, we call it as parametric tests. If no parameter is used, we call it as non-parametric tests, that's all. So whenever certain parameters are used, we call it as parametric test. And if no parameter is used, we call it as non-parametric test. Then the next question is, what is a parameter, sir? Yes. See, mean and standard deviation. Mean and standard deviation. In this case, for applying any statistical tool, if these parameters are used, then we call it as parametric test. Either mean is used, or standard deviation is used, or variance is used. These three are the most widely used parameters in applying parametric tests. So mean, standard deviation, variance. Mean is calculated, standard deviation is calculated. Then what is the variance, sir? Variance is nothing but the square of standard deviation. So we have calculated the standard deviation here, 22.076. The variance is just the square of this standard deviation. So obviously, standard deviation and variance are related like this. The square of standard deviation is variance. The square root of variance is standard deviation. That's all. So in applying any test, if the parameters are used, any of the parameters, either mean or standard deviation or variance is used to test the data, it is called parametric test. If such parameters are not used, we call it as non-parametric test. See here, we have certain data, see age group, gender, ranking, and all given, then perception. See, instead of the satisfaction, only one factor I have considered, right? Only one factor I have considered. That is satisfaction on CRM. Suppose we have several factors. See, for example, satisfaction 1 on first factor, then satisfaction on second factor, satisfaction on third factor, fourth factor, satisfaction on fifth factor, right? See here, factor 1, right? Now, here we have assigned the scores only. Suppose if we want to have the overall score or the total score of satisfaction, if individual factor is concerned, so for example, satisfaction on factor 1, satisfaction on factor 2, we have assigned just the scores. In case if we want to assess the total satisfaction, so it is overall satisfaction. Overall satisfaction. Here we have to total the values and we have to enter it here. For this, it will be easy for us if we open up any Excel data sheet.
Hello.
Sir?
Yes, sir. Sorry to interrupt in between.
Sir?
So many are asking for the output sheet, sir, actually.
Yeah. I'll show it. Huh?
They're requesting. Okay. Yeah.
Okay. See here, what I want is, I want to have the total of these columns, right? I want to have the total of these columns. For this, we can have the total values easily in this Excel sheet, right? I entered here. here I want to have the total. For that, you can use the alt and plus. Alt and plus. I have got the total. Again, it can be copied and pasted. So this is the total value of satisfaction. So here we are entering, just copy and paste. Okay, right. Now let us discuss about the dependent variable and independent variable. See here, overall satisfaction is here. The gender is there, age group is there, gender is there, and overall satisfaction is there. In this case, the overall satisfaction is the exact values. So instead of assigning just 1, 2, 3, 4, and 5, we have got the total score of all the 5 questions, all the 5 factors. So here 12, 18, 20, and 21 are the exact values. So the total scores are available. So there will be a meaning if we calculate the mean for this. Calculate the mean for this. So overall satisfaction. Right. See, this is the output. Overall satisfaction, minimum 12, maximum 21. The mean satisfaction score is 17.75. Then standard deviation is 4.031. That's all. See the difference. In the previous case, it was a ranking question. There is no meaning for the mean and standard deviation because it was just like that a score or just like that an identification. But here scores are there. We have entered the total score here. So we can compute the mean in a meaningful way. See the difference. So mean and standard deviation should not be computed for this type of data, either for the nominal data or for the ordinal data or even for just scale. So here what I would like to tell you is the mean, standard deviation and all can be calculated only for the data which has no classification, which has no value labels. In that case also we can assign the scores. We can calculate the mean. We can calculate the standard deviation. We can calculate the variance. That's all. So now the difference between parametric tests and non-parametric tests. Dependent variable and independent variable. See here, we consider 2 variables, that is gender and overall satisfaction. We want to assess whether there is any significant variation, whether there is any significant variation in the overall satisfaction of the respondents with reference to gender, So here gender is independent variable and satisfaction is the dependent variable. That's all. We are not concerned about the independent variable, whether it is nominal or ordinal, no bother at all. Because what is the testing variable? The dependent variable is the testing variable. So if the dependent variable is given like this. See, age or the overall satisfaction. So exact values are given. If the testing values, the testing variables are given in exact values, or the dependent variables are given in exact values, then only we can calculate mean, standard deviation or variance in a meaningful way. In that case only we can apply parametric test. Otherwise, parametric test should not be applied. In that case, we have to apply the non-parametric test only. See here, I told you we are comparing gender and overall satisfaction. Gender is an independent variable. Overall satisfaction is a dependent variable. We are comparing gender and overall satisfaction. The overall satisfaction data is given in exact terms, in exact values. That is, the total score is computed and given. In that case, if we compare gender is an independent variable. Whether it is a nominal data or ordinal data, don't bother. Because the testing variable, that is dependent variable, is the overall satisfaction. It is given in exact values. So we can apply the parametric test. We can apply the parametric test. Suppose if we want to compare the gender and satisfaction on factor 1 individually, instead of comparing the overall satisfaction, if we are comparing the individual factors, in this case, please understand, there is no exact values. It is just assigned. 1 for highly dissatisfied, 2 for dissatisfied, 3 for neutral, 4 for satisfied, and 5 for highly dissatisfied. Whatever it is, if you calculate mean, it will be like this only. Always the minimum will be 1. The maximum will be 5. The mean will be like this only. Isn't it? So there is no meaning in at all. Meaning in it. In that case, you have to apply non-parametric test. If the exact values are considered, then we can apply parametric tests. This is the basic thing you have to understand, where we can apply the parametric test and where we can apply the non-parametric test. Very simple. Simple definition is there. If some parameters are used, we call it as parametric test. And if no parameter is used, it is called non-parametric test. Sir, when the parametric test is to be applied, when non-parametric test is to be applied, if the testing variable is given in exact values, then we can apply parametric test. Otherwise, we have to apply the non-parametric test. That's all. That's all about the basic things. Now let us go to the parametric test and non-parametric test. Sir, Sajan sir, are there any questions?
Yes, sir.
Yes.
Everybody is asking for the output. They want to see the output and result.
See, this is what output I am showing now. Is it visible or not? Sir, is the screen visible or not?
Screen is visible, sir. Overall status, perception, everything. Thank you.
Yes. This is what output. Okay. And
okay.
This output can be exported to the Word file, Word document. Before that, we can copy and paste. See here, if you click the right click, some menu is appearing, cut, copy special, like that. See here, export is there. Either you can directly export by using this option, or otherwise you can just copy. I don't know, copied. Instead of pasting in the Word document directly, we can paste it in an Excel sheet like this. Here also use the right click. Some paste special option is there. Don't paste it as it is. You select the paste special option. Right. A sub window is appearing like this. Here you select Unicode text. Unicode text. Then OK. Now this is the table. This table can be copied and pasted again in a Word document. So copy and paste it in a Word document. Right? We have pasted it. Here also you have one small box here. Paste options. Left click. Here several options are there. Keep source formatting. Match destination table style. Paste as a picture. Keep text only. So these are the 4 different types. First one, keep source formatting. If you click this, it will be as it is. But we have to select the match destination table style. If you select this, see the table is converted like this. See the borders are displayed. Borders are enabled. Right? Now we can align this table. See, a square is appearing at the top of the left top corner of the box. You just select it and right click. If you right click, see here, auto fit option is there. Auto fit. So auto fit to contents. Auto fit to contents. If you select this, it will be appearing like this.
You have shared SPSS window. That is the reason we are not able to see the output. So can you, if you share the desktop window, it can be seen to everybody, sir. So we are not able to see the output. Yeah.
Don't you see the Word document now?
No, no. We are not able to see it. It is only SPSS window.
Okay. So this is the problem in Zoom.
Yes.
See here, I have to close it and share the. Are you able to see the output now?
Yes. Yes.
Okay. Right.
It's better because the questions are asking from the quite long time. Everybody wanted to see the output. So if you bit explain about it, it is a great.
Okay, sir. Okay. Similarly, I can show the Word document also. See, this is the output. Let me do it again. So I have copied and pasted here. You select the options here. Match destination table style, paste as a picture, keep text only, like this. We are selecting the match destination table style. So the table will be displayed like this. There is a square at the left top corner. You select that. So the entire table is selected now. Then right click. Then a window appears like this. Auto fit. You select auto fit. Then go to auto fit to contents. auto fit to contents. See, the table is now aligned like this. Then if we want to have the table in the center, you just click Control E, right. Now we want to have the data aligned in the center, right, or else we can have the table fit to window like this also we can have, right. Auto fit to contents, auto fit to window like this also we can display different styles. Then here, see, let me show the difference here. The next one is paste as picture. If we select this option, the table will be appearing like this. We cannot change it. It is displayed as a picture. We cannot change anything. It will be, see, like this only. So we cannot change it. It is displayed as a picture, right? So other thing, keep text only. See here, no table is displayed. Just the data are displayed. So that's why I told you to select the destination, match destination table style. So here you can change it anything like this, right? Anything else. If you don't want this, you can delete. Like this, whatever changes we need, we can do it. That's why we have selected this option. Okay, right. Sir, are there any questions regarding this? Or
Can
shall
I
we go to
unmute?
the...
Huh.
Ah,
Can I keep it at the end, or should I ask the participant to ask the question now?
yes, sir.
Okay, okay then. So let me unmute Maftan sir. You can ask the question now.
Okay.
Hello, sir.
Sir.
So I had this. I should ask this question at the before some hour before. So this the chance it's about the age group and the age.
Yes,
So
yes, yes, yes.
as we know, age group it is just nominal. You choose it as an ordinal.
Yes.
So nominal we just classified it. We just classified it between 20 as a, let's say, adult or young, from 20 to 30 as an adult, like that. We just classified it. We should choose it as nominal because we just classified it to groups. But you choose it as an ordinal. We didn't order it. And in another place, you just put it as an age.
Yes.
On age. According to me, I think it should be scale because we can measure it. And you choose it as a nominal. Why? Why we choose it as a nominal?
So here, no scale is assigned here, right? See, scale is assigned like highly satisfied like that only, right?
No, age, yes, age.
Age, yes, yes. See here, this one.
Yeah.
Right? Here,
yes.
We are assigning no values here. See here? No value is assigned here.
No value, it should be scale. No scale.
No scale is assigned here.
Okay.
No scale or no value is assigned here.
Okay.
So we consider as a nominal. That's all.
Okay.
In the case of age group, as you asked, the values are assigned in an order. So only we call it as ordinal data. See here, 1 for below 20 years, 2 for 20 to 40 years, 3 for 40 to 60 years, and 4 for above 60 years. It is in an order. Sir?
We shouldn't consider it is as a nominal because we divided it to groups. First group, it is below 20 years.
Sir, we have divided it into groups, but
Okay.
the groups are assigned values in an order.
Okay.
See, whereas in the case of gender, see, I have categorized as this nominal value only, nominal data only, because there is no order here. I told you no. You can exchange. You can exchange the scores. One for female and two for male, or one for male or two for female. Whatever value you want to assign, you can change it. It is not in an order. So we call it as nominal. That's all.
Thank you. Thank you.
Okay, sir. Okay.
Sir.
Okay.
Any other questions?
Yes, one more person, Dr. Sheikh Karim. So let me unmute.
Oh, yes, sir. Please.
Yes, sir. You
Sir,
can ask the question.
good morning, sir.
Good morning, sir. Good morning.
Sir, I am audible, sir?
Yes, sir. Yes, sir. Please.
Yes, sir, you
Sir,
are.
first of all, congratulations. You have used a very lucid example, sir.
Thank you, sir. Thank you.
I'm Dr. Sheikh Karim, Associate Professor, Free Vidyananda Institute of Management, and also a statistician, sir.
Oh,
The same
nice,
question
sir.
previously which was asked, there is only at one point where the needle is stopping at age, which you
yes,
have
sir, yes,
used.
sir.
First, it's okay, sir. First one, age is an ordinal, sir. But
Yes, sir.
again, when you have used age in the 10th row, age, numerical, see, I am getting that, sir. You have mentioned it as a nominal, sir, because it is having all the properties. It has
Yes, sir.
order as well as scale. So it is more suitable for to be a scale, sir. That's what I am getting doubt, because you said when about parametric and non-parametric test, we
Yes,
can
sir.
use parametric test, t-test for this one. For example, with gender, is there any significant difference in the age of male and female? That's the clarity, sir. What I need for this one. That is somewhere.
Right. See here, why we have considered age again? Even though there is an age group, we have assigned here age. We have considered one more variable as age. Suppose if the age is considered as a dependent variable, or if we want to analyze the average age of the respondents, in that case we need the age as exact value. For that purpose only we have considered the variable. Again, it is just for an example. Okay, if it is given in exact values, then only we can calculate the mean or a standard deviation or variance. If it is given as group, there is no possibility to calculate the average or mean age of the respondents.
For example, sir, in 10th we can calculate the mean age of male and female. We can do that one.
We can do that. We can do that.
So it will not be an ordinal or nominal. Then it will come under either interval, or we can calculate mean age of male, mean age of female. That is the possibility is there. So that's the possibility.
That's why we have taken here as the age. So we can compare the gender as well as the age. For that purpose only we have considered. In that case, it shall be treated as the
t-test. We can use it, sir. We can use t-test. So in that scale, it should become as a scale, and it cannot be considered as a.
In that case, we can use it as scale, sir.
Scale. So thank you, sir, for your lucid explanation, sir. Once again, Sajjan sir also for taking this one, sir.
Thank you
for giving.
There are a few questions, sir. Can I ask the end of the session, or you can continue? I will ask a few questions at the end.
You can ask that. You can ask that, please.
You can ask now. Okay, fine. There are a few questions like, sir, if I have collected the data and converted it to Excel, how can I transfer it to SPSS? A person called Hannah Jacob have been asked this question in a YouTube. So please, sir.
Yes, sir. Yes, sir. See, this is the Excel sheet, right? I have some values. See, these are the values I have. See, just copy. You just copy. Then go to the, see here. See, this is the SPSS data sheet. So here you can just paste it. That's all. But the thing is, we have to define the variables. We have to define the variables. See here, let me start. Right? See, in the Excel sheet, we have got the data, and now we are copying and pasting here simply, right? Copying and pasting, right? But the thing is, after having copied and pasted, we have to define the variables here as earlier, as group. 0, 2, again 1, 2, 3, 4 as it is. To 60 years, 4 above 60 years. So it is ordinal. Gender. Like this only we have to do so. Okay, sir. Just you can copy and paste it from Excel sheet to SPSS sheet. You can just copy and paste it. But the thing is, you have to define the variables. Without fail, you have to define the variables. Then only you can do the, or you can perform the analysis, right?
Yes. So thank you, sir. And
Okay,
I hope Hannah Jacob can able to get the information.
Okay,
We'll proceed the session, sir. And at the end, if any questions are there, I'll ask it, sir. Yes.
Okay, sir. Okay. So now let us. Now we'll go to the problems. Now, for the purpose of easy understanding, and the saving in time, I have given you a data set and problem for each and every parametric and non-parametric test. See problem number 1. Now, I told you no, parametric and non-parametric tests. There are basically two types of tests of hypothesis. One is parametric test and other is non-parametric test. When some parameters are used, we call it as parametric test. And if no parameters are used, we call it as non-parametric test. In the case of parametric tests, it can be broadly classified into two types. One is t-test and the other is ANOVA. T-test and ANOVA. The t-test is again divided into 3. That is one sample t-test, independent samples t-test, and paired samples t-test. Parametric test, non-parametric test. T-test, in the case of parametric test, there are two categories, t-test and ANOVA. In the case of t-test, there are 3 tests. One sample t-test, independent samples t-test, and paired samples t-test. In the case of ANOVA, one-way ANOVA and two-way ANOVA. That's all. Now let us see one by one. See, one basic concept we have to keep in mind is, in the case of t-test, it can be applied only when there are a maximum of 2 groups or 2 samples. Either there is 1 sample or there are 2 samples or 2 groups, for your easy understanding, 2 groups, then only we can apply the t-test. If there are more than 2 groups, 3 groups, 4 groups, or 5 groups like that, in that case, we should not apply the t-test. We have to go for the ANOVA. We have to go for the ANOVA, that's all. So this is the basic difference between t-test and ANOVA. If there are a maximum of 2 groups, then we can apply t-test. If there are more than 2 groups, then we can apply ANOVA. Understand? If there are more than 2 groups, t-test should not be applied. Suppose if anybody is telling, no sir, even if it is there, even if there are more than 2 groups, I want to apply t-test only, sir. You can apply. How? You can compare 2 groups separately. Group A versus Group B. Group B versus Group C. And Group A versus Group C. In either of these cases, only 2 groups are compared. In such a way, we can apply t-test. If all the 3 or 4 groups are compared together, t-test should not be applied. In that case, you have to apply ANOVA only. Understand? Okay. Then here, t-test. I told you, no, there are 3 types of t-tests. One is one sample t-test. The second one is independent samples t-test. And the third one is paired samples t-test. In the case of one sample t-test, we don't classify the samples into several groups. All the samples are considered as a single group only. No classification of samples into, see, like male and female, below 20 years, 20 to 40 years, 40 to 60 years, like that. Altogether, all the samples are considered as a single sample or single group. In that case, one sample t-test is to be applied. See, in this problem, Govindadasa College has conducted a coaching class for bank exam. The overall average marks obtained by all the candidates in the bank exam was found to be 150. GDC claims that those who have attended the training or coaching in this college have performed better than the overall average of the candidates in the bank exam. The marks obtained by the GDC candidates are given below. See here, only one sample, that is all the 25 students are GDC students or GDC candidates. So no classification, no male, female, no age group, no discipline, commerce, management, science, no such a categorization is there. All the 25 students are considered together as a single sample. And here, see the 150. What is this 150? This 150 is the average of the population. See, average marks, overall average marks obtained by all the students in the bank exam, all the candidates in the bank exam. So it means It is the population average. So the conditions for applying one sample t-test is that we should have only one sample and we should know the population parameter, that is population mean is given. It is given in the problem itself. See, 150. 150 is a population average. Now the data for 25 students are given. Now the question is, you are required to test whether GDC candidates have performed better than the overall average of all the candidates appeared in the bank exam. So this is the question. Now we shall go to the data. See, this is the data set I have considered. Here the marks are entered. See, I have defined the variables in a preset manner for the sake of time saving. See, this is a variable, that is mark, average marks obtained here. See, what we have shared in the previous case, that is in the Word document I showed, candidate 1, 160 marks, candidate 2, 143 marks, candidate 3, so and so marks, like that. We have given, see here, score for 25 candidates are given. So these are exact values. Marks are given, not the value assigned like 1, 2, 3, and 4 like that. It is not like that. So actual marks are given. If actual marks are there, we can calculate the average. So we can apply one sample t-test because all the candidates are the trainees attended in GDC college. So they are taken together as a single sample, right? So one thing, they are considered as single sample, and the other is actual values are given, and the third one is population parameter is known. Now we shall go to the analysis. See, analyze.
Sir, please share the screen.
Hello, sir.
Please share the screen, sir.
Is it not visible?
No, it is not visible, sir.
Yes. Right?
Yes. Yes.
Okay.
Yes.
See, the marks are here. Now we'll go to the analyze button. See, this is the only gateway. For all the analysis, this is the only gateway. See here, we have compare means. We have compare means. See here, means, one sample t-test, independent sample t-test, paired sample t-test, and one-way ANOVA. For all these things, there is only one gateway, that is analyze, compare, means. Here, what I told you, for this problem, we have to apply one sample t-test. We have to apply one sample t-test. So select this, one sample t-test. We have selected. What is the test variable? That is marks obtained by the candidates. So marks obtained by the candidates. See, please remember that test value, many scholars commit mistake here, that is, they are not considering this test value. This test value is nothing but the population average. What was the population average in our problem? Population average was 150. So here we have to enter 150. So test variable, marks obtained. Test value 150. That's all. Go to OK. Go to OK. See here, 150 This is the output. See, this is the output. See here, mean, number, mean, standard deviation, standard error. See here, t value, then degrees of freedom. Then this is called p value. This is significant value. It is p value. Mean difference, then confidence intervals, a lower interval and upper interval. See here, the deciding factor is the p value. Deciding factor is the p value. This is what we are going to use for determining the result. See here. See, this is the output. Okay. So before performing any analysis, it is mandatory to formulate the hypothesis. Without hypothesis, your analysis will be meaningless. So we have to formulate the hypothesis here. So two hypotheses are there, null hypothesis and alternative hypothesis. The null hypothesis says that there is no difference. There is no significant difference between average marks obtained by the GDC candidates and the overall average of all the candidates in the bank exam. This is the null hypothesis. In the case of alternative hypothesis, there is only one difference. That is, instead of no, we are using A. That's all. Right? So this is the result. See here, as I told you, we have to consider this p value only for deciding the result. So what is the p value here? 0.019. 0.019. See, what is the null hypothesis here? There is no significant difference between the average marks obtained by the GDC candidates and overall average of all the candidates in the bank exam. Normally, we consider the level of significance as 5%. Level of significance as 5%. Generally, we take it as. If we are considering it in a strict manner, we have to consider 1% level of significance. If it is considered in a liberal way, then we can have 10% level of significance. But generally, we take 5% level of significance. Now, the thing is, 5% means 0.05. 5% means 0.05. See, as I told you, this is the p-value. This is the p-value. What is the p-value here? 0.019. 0.019. For the easy understanding purpose, I tell you, this is the possibility of or chance of happening the null hypothesis to be accepted. This is the possibility to accept the null hypothesis. So here, what is the level of significance? 5%. That is 0.05. 0.05. What is the p-value? 0.019. You can simply remember that, as I told you, the p-value implies, that there is a possibility for accepting this null hypothesis to this extent. Here, what is the level of significance we have considered? 0.05. If the p-value is greater than 0.05, if it is greater than 0.05, so because normal p-value is 0.05, that is significant value is 0.05. If it is greater than 0.05, then we can accept the null hypothesis. We can accept the null hypothesis because limit is 0.05. But here, there is less possibility because p-value is less than 0.05. That means there is a lesser possibility of accepting the null hypothesis. So you reject the null hypothesis. I have rejected the null hypothesis because the p-value is less than the significant value, less than the 5% level of significance. So the null hypothesis is rejected. If the null hypothesis is rejected, obviously we have to accept the alternative hypothesis. What is the alternative hypothesis? There is a significant difference. There is a significant difference. What is our question? Our students have performed better than the overall average. Our students have done better than the overall average. That means there should be a significant difference. Yes, we have got the result. But the question is whether our students have performed better or not. For that only, we have to compare this parameter value with this sample value. What is the population parameter? 150. That is overall average score obtained by all the candidates. What is the average score obtained by our candidates? It is 166.84. So it is greater than the overall average. So we can conclude that GDC candidates have performed better than the overall average of all the candidates in the bank exam. Right? This is what about the one sample t-test. Right? Is there any doubt regarding this? You can ask, or otherwise we can have a break because it is 12:05. Huh? Sajjan,
Okay.
sir?
So far, there is no any doubt as such. There are a few doubts which are not linked with that I will ask at the end of the session, sir. So,
Okay.
I mean, the fourth session I'm talking about. So,
yes, sir. Yes,
shall
sir.
we end up now or we can continue in the next session, sir?
Yes, sir. Yes, sir. We can come back by 2 o'clock. Huh?
By 2 o'clock then. Yes, then, okay.
Okay, sir.
Okay. Should I ask 2 questions here?
Yes, yes, sir. Yes, sir. Please.
Okay, there is Sonali Sophia Fernandez who asked a question like how to do level of knowledge, how we can give values to it.
Sir,
For the level of knowledge, how we can give values.
Level of knowledge and values. I showed you know satisfaction 1, satisfaction 2, satisfaction 3, like that, no? Right? So for each factor, we have considered the values assigned. That values have been converted into total score by summing up. Right? By summing up, we have calculated the overall score. So that overall score can be used for parametric test. Right? Again, suppose as you asked, if you want to convert it again into levels like low level, medium level, and maximum level, in that case, we have to see. Is it visible now, sir? Excel sheet?
No, sir, it is not.
Okay, let me show this.
Yeah. Yeah.
Okay. For example, here, factor 1. Like this. Okay. Okay. See, these are the scores we have assigned for individual factors.
Okay.
If we want to analyze individual factors separately for F1, F2, F3, F4, F5 like that, then in this case, we can take these values as it is. So highly satisfied, satisfied, neutral, dissatisfied, and highly dissatisfied. Like that, we can have it as it is, one thing. This is one way of analysis. Another one, as I told you, the total score. Right? The total score can be computed, as I told you, use Alt plus. Then you can drag it.
Okay.
Now the values have been arrived at. We have ascertained the values. So if values are there, we can apply parametric test. We can apply parametric test. But for these individual factors, we cannot apply the parametric test because no values are there. Right? Now, madam's question is how to convert this score into levels. As I told you, low level, medium level, and maximum level. Right? So here, level of awareness or level of satisfaction, whatever it is. Right? See, how many factors we have considered? We have considered 10 factors. We have considered 10 factors. Okay. Then what scale we have adopted? 5-point scale. So that is highly satisfied, satisfied, neutral, dissatisfied, and highly dissatisfied. Total factors considered 10. Total scales considered 5. Now, could you tell me what could be the maximum score of any respondent? See, if one respondent has given a response for all the 10 factors as highly satisfied, then what could be the maximum score? 5, 5, 5, 5, 5, 5, 5, 5. So 50. 50 could be the maximum score. Am I right? So 50. What could be the minimum score? For all the 10 factors, if he has selected highly dissatisfied. So 1, 1, 1, 1, 1, 1, 1. For 10, we have 10. So what is the maximum score? 50. What is the minimum score? 10. Right? What is the difference? 40. What is the difference? 40. So maximum score 50, minimum score 10. The difference is 40. Now, how many levels you are going to classify? How many levels you are going to classify? 3 levels. You told no? Low, medium, and high. Low, medium, high, and high. 3 levels we are going to classify. So you divide the 40 by 3. Divide the 40 by 3. So 40 divided by 3. We are getting 13.333. So here, what is the minimum score? 10. So 10 to 23. 10 to 23. Right? Because 13. See here, 13 is the average. 13 is the average of the difference. See, maximum score 50, minimum score 10, difference 40. That for that 40, we have ascertained the average depending upon the number of levels we are going to assign. So we are going to assign 3 levels. So low, medium, and high, 3. So 40 is divided by 3, we are getting 13. So 10 to 13 will be considered as low level. Then 24 to 36, let it be. It will be considered as medium. Then 37 to 50 will be considered as high. Understand? Then we can assign the values here 1, 2, and 3. Can assign values here 1, 2, and 3. So what is the base? 10 to 23 means 1. 24 to 36 means 2. 37 to 50 means 3. See here, we cannot individually look at every total score and assign. See here, 25 is there, total score. So what we have to assign? 24 to 36 means we have to assign 2. So if number of respondents is less, we can easily assign. If it goes to 200, 300, 400, we cannot assign easily. So here there is an option. See here, you can select the filter option. You can select the filter option. Filter. See, down arrows are appearing like this here. So select the total score. Select the total score here. Then you select the number filters. You select the number filters and you go to the between. Go to the between. Then if you select the between, a window will be appearing like this. That is, it is greater than or equal to and is less than or equal to. See here, we have taken 10 to 23. So here you enter 10 and here you enter 23. Then OK. See here, only those things are selected. Here, no item is there in that category. In low level category, no item is there. So what is the second item? We have to go to again between. So here 24 to 36. 24 to 36. Some items are there. We can assign 2, 2, 2 like this. Or you can drag it to. So like this, we have converted into levels. Similarly, the third one, that is number filters between 37 and 50. So here also no item is there. But in fact, if actual data is collected, you will be getting at all levels. So like this way only, we have to convert into levels. So individual factors are converted into total scores. Total scores are converted into levels of knowledge or awareness like this only.
Thank you, sir. And, yeah, right. And we have one person called Azazuddin. And Azazuddin, sir, I will give option for you at the end of the fourth session. Hence, the time is lagging over here.
Okay.
Thank you, sir. Thank you for the wonderful session over here. And sharply, we'll meet at 2 o'clock for the second round of the session. the
Sure,
post
sir,
lunch.
sure.
Okay.
Thank you.
Now
Thank
I
you very much. Thank
request, yeah, thank you, sir. Now I request all the participants, we are going to drop the session 3 assignment now. Session 3 assignment now. Please fill it within 20 minutes. We will be giving 20 minutes time. Please copy the link. First of all, please copy the link somewhere else. Then you can process with the assignment. There are a lot of people who will miss the link, then will ask for the link. So whenever that we drop the link in the chat box, please copy and keep it with you. It has a valid till 5 o'clock. So before 5 o'clock, you can fill up the assignment and you can submit to us. So now we are going to drop the link in the box. Chat box. Please do your assignment. 20 minutes it will be on. So thank you, Kumar Senan sir, and we'll meet sharply at 2 o'clock for the next session. So thank you,
Sure,
sir.
sir. Thank you.
Yeah. Yeah. I repeat to everyone, please copy the link which is shared in the chat box and submit it before 5 p.m. today so that you will able to get the third certificate of today's FTP program. So please copy the link, whatever we have been shared in the chat box. So till 12:30, the link will be available in the Zoom as well as in YouTube. Okay, I have. Okay, I have dropped the assignment link again in the chat box. I request everyone to copy the link, and it is valid till 5 o'clock. And please submit your assignment before 5 p.m. So I will close the meeting now, and exact 2 o'clock, the session 4 is gonna begin. So please be here at 1:45. Please relog in at 1:45. Exact 2 o'clock. We're gonna start the session number 4. Thank you, everyone.